Okay guys, we're going to look at these one at a time. We're looking at three-phase here, and we're going to talk about the Y configuration of three-phase. So I've taken my AC alternator here and connected it Y, and I've got my phase voltage. Let's just say that this particular machine is outputting 120 volts phase voltage, okay, and I'd be able to measure that in three different places there. And so the question is, if I connected it this way, and I know my phase voltage is 120, and there's my 320 volt, sine waves. The question is, what is the voltage at the output here? And, the best way to look at that, guys, let me get a piece of paper here, is to notice that if I choose, and I got my line voltage, it's drawn here, okay, but it would also be here, right, guys? And I would also be able to measure it here. They're going to be the same. No matter which two wires I choose, I'm going to get the same line voltage. So we're just going to look at, two of them so that we're not too confused. And if you look at it, I got 120 volts being generated here, and I have another, 120 volts being generated here. And if I ignore this one, okay, guys, I can see that those two 120 volt phase voltages are connected in series. And so the question is, what's your voltage from here to here? Well, the answer is it's going to be this 120 volts, plus that 120 volts. Now, unfortunately, it's not going to be 240 volts because those two voltages are out of phase by 120 degrees. And so if I were to take a look at this phase, this diagram here as phasors, what I would end up with is, here's my red phaser, okay? We're talking about the three phase voltages here. Here's my, black 120 volt phaser. That's 120 degrees out of phase there, guys. And here's my blue phaser here, guys. 120 volts, okay? And so if I take, let's say this is the red one, and I add it to, let's say this is the black one, okay, the question is, what is the total voltage? And, some people who know a little bit about three-phase by now, they might go, well, it's the sum of the two, and it's going to be equal to this line right here. And it's not quite right, guys, because believe it or not, maybe you guys know this, okay? But if I have a 120 volt system like this, then my line voltage is 208, right? It's not going to be 120. And that's because the phasor sum of this 120 and the phasor sum of that add up to 208. But that's actually not what's going on here, guys. In three-phase, you're not actually adding these two phasors, you are subtracting them, because if I added these, guys, what I would have to do is take this one and move it tip to tail, and so it would end up over here, guys. I'm taking this black one, picking it up, moving it tip to tail, and the resultant would be the line that's right here, and that's actually not what's going on. These are actually being subtracted, and when I subtract a phasor, guys, I had 180 degrees to the phasor being subtracted. Ends up coming down here, okay, and then I move it tip to tail, okay, so that phasor ends up right here. I can make that a solid line, I guess, okay. So there's my 120 volts that's being subtracted, and the sum of the two is going to be, let's get a purple line going here, right? This line right here. Now I'm going to tell you right now, guys, that line there is going to be 208 volts, okay, and that's just the way it is with this, but in order to prove it, we're actually going to calculate it the hard way, okay, guys? So if I take that, this is 120 volts, guys, and it's at, what, 0 degrees, right? And let's take that one. Just to make it simple, guys, we're going to put it up here because it doesn't make any difference, right, guys? So it's sitting right here. There's my 120 volts. And it's going to be actually at 60 degrees, okay? It's 120 degrees here, which means it's 60 here, okay, so it's 60 degrees, all right, and the sum of the two is this purple line right here. Well, this is the resultant, right? And we know how to calculate this, right, guys? It's going to be the horizontal component, guys. going to be 120 cos 0 plus 120 cos 60, right? And the vertical component is going to be 120 sine 0 plus 120 sine 60, right guys? And let's actually bring our calculator in here and calculate that real fast here. 120 cos 0 plus 120 cos 60. Looks like our horizontal component is 180. Okay, and we're going to do exactly the same thing for the vertical component. 120 sine 0 plus 120 sine 60. Looks like it's 103.9. All right, and I know this is tedious, okay? But bear with me here, guys. So the resultant for this particular guy, guys, is going to be 180, squared plus 103.9 squared. You feel me, guys? There's your horizontal component, right? And there's your vertical component, HCVC. Let's calculate that. 180 squared plus 103.9 squared equals root equals, and look, it's 207.8, okay? So there's where that 208 volts comes from. Okay, 207.8 volts, okay guys? So 207.8 volts, all right? And so what that means is, guys, if I measure here, I'm going to get 120. If I measure here, I'm going to get 120, guys. And if I measure here, 208. All right, guys? And it doesn't matter where I measure. I can measure here, here, or here. 208 if I have a three-phase Y. Now, this is a pain in the butt, right? Because I'm not going to, am I supposed to expect you guys to do, all this work every time? Well, no, guys, because the formula for calculating the line voltage is this one right here, okay? If you know the phase voltage of a Y system, guys, and you want to calculate the line voltage, you can take the phase voltage and multiply it by √3. And if we try that here for a second, let's try it right down here, because this is too much work, right, guys? According to this calculation, we'll separate it out like this. E line, guys, should be E phase times √3, which means it's phase voltage 120 times √3. And if I try 120 times √3 equals, look at, can you see it? 207.8 volts, okay? 207.8 volts. All right, guys? So I showed you the long way. Why is it 207.8? Because it's the phasor sum of these two. But we're not going to be drawing tons of phasors here and trying to figure out our line voltage if we know our phase voltage. What we are going to do is simply multiply our phase voltage times √3. Now, why does that work, guys? Well, I'm going to show you something for a second. All right, guys? Let's test. Let's just say, hypothetically, I had a three-phase system and it was 1 volt. Okay, so here's my Y-connected three-phase system, and the phase voltage was 1. All right, so I just want you to bear with me for a second here. E phase is equal to 1 volt. Well, that means that the line voltage, guys, would be 1 plus 1, but it would be the phasor sum of the two. So if I actually looked at that, I would have 1 volt there, right? And 1 volt here. Okay, that would be the two phasors. That would be 60 degrees, right? And the resultant should be this line right here, right, guys? This is the resultant. And if I calculated the horizontal component, guys, and I know we just did this, but I want you to see it, it's going to be 1 cos 0 plus 1 cos 60, right? And the vertical component would be 1 sine 0 plus 1 sine 60. All right, guys? And if we calculate those real fast, let's do it. 1 cos 0 plus 1 cos 60. You know, don't write all this down, guys. Just watch. Okay, 1.5. All right, guys. And then 1 sine 0 plus 1 sine 60. Looks like it's 0.866. Okay, which means the resultant, guys, and I'm going to do this the long way here, it's going to be 1 squared plus 866 squared. Okay, so, oops, 1.5, right, guys? Let's try that for a second here. 1.5 squared. So it looks like it's, you know, 2.25 plus, and then I'm going to go 0.866 squared. 0.75, okay? And if I add those together, guys, 2.25 plus 0.75, it's the square root of 3. All right, guys? And so that's where that root 3 comes from. All right? And just do it. Okay? It's going to work every single time. Now, we're going to quit this video in a second, but I want to talk about one more thing. All right? And that is current. Because for a second, imagine for a second that I had 10 amps flowing out. You know, there's some load out here, and it's causing 10 amps to flow in these 3 wires. Okay? The question is, you know, if that's, and that would be I line, right, guys? Since this is the wires going in and out. The question is, for a 3-phase Y-connected system, if the current on the wires here is 10 amps, what's the current through the phase? And, you know, the answer is it's going to be the same, because if I have 10 amps on this wire here, guys, then it has to be coming through this phase here. In other words, if I clamped on over here, which would be I phase, okay, it would also be 10 amps. Same with over here. I mean, really, I'm just taking my clamp on ammeter and moving it down, right, to the phase. Same with this one. Same with this one. Why I'm telling you this? Because the other formula for Y, guys, is, whoops, not I line, okay, is equal to I phase. All right, guys? And that will always be true for a Y-connected system. E line will be E phase times root 3. I line will be equal to I phase. All right, guys? And so let's try one real fast, just a little bit different here, guys. We're going to get a brand new piece of paper here. And I'm going to draw a Y-connected system here just for fun. I'm making this one up, you know, out of thin air. All right, guys? Okay, and what I'm noticing over here is that E line is equal to, you know, 600 volts. In other words, I'm measuring with a meter from here to here, and it would be measured here and there also. My question for you guys is, you know, and you can pause this video and try to figure it out and come back and see if you're right, okay? So my line voltage is going to be 600 volts, guys, and my line current, I line, is going to be 70 amps, okay? And so the 2 questions are going to be, what is E phase? And what is I phase? Okay, so pause your video. Try this out. Come back, and I'll take it up. Okay, we're going to take it up now. Okay, so line voltage is 600 volts. Question is, what is E phase? E phase, E phase. Well, the formula is E line is equal to E phase times root 3. All right, guys, and so we know the line voltage. We're trying to calculate the phase voltage here. I have to transpose this. E phase is going to be E line over root 3, okay? And it's going to be 600 over root 3, all right? And I'm going to calculate that right now. 600 divided by, where's my roots thing? root 3. 346. Okay, guys? 347. That's where that 347 600 comes from. Okay, guys? Now, what's my phase current? Well, I line, guys, equal to I phase. Okay, so it's 70 amps. All right, guys? Thanks for sticking around for me, and come back for delta.